On this video, we're going to revisit a problem that we've seen before, which is solving a quadratic equation, but we're going to see this from the perspective of how that equation is related to a curve and the x-intercepts of that curve. So I'll show you what I mean. We're going to start by something you've seen before. So solve. Let's say this is a quadratic equation. Okay. So if I solve this equation, well, what I'm going to use a factoring method if possible. So let's see, a product is going to be, I want to split the middle term, 15x, right? And for that I need to use two numbers such that their product is 4 times 9, which is 36. So the product of A and C, and the sum is 15. So looking at the factors of 36, I need to find two of them that are positive, right? Because they need to add up to 15. And they're positive because 36 is positive. And the sum of the factors is positive. And so they need to add up to 15. So 3 and 12 will do. So 4x squared plus 12x plus 3x plus 9 equals 0. You split the middle term. You factor by grouping. Like that. So it's going to work if you find x plus 3 in both terms here. And if that's not the case, that means you picked the numbers wrong. But here it works. Keep factoring, and now I use the zero product rule. If I've got a product that's equal to 0, one of the terms and one of the factors in the product is going to be 0. So that means 4x plus 3 is 0, or x plus 3 is 0. And then if I solve for x, you send 3 on the other side, and then you divide by 4, minus 3/4, sorry, or x is minus 3. So those are the two solutions. Okay, all right, we've seen this before. Now, let's think now about, let's say I were to graph y equals 4x squared plus 15x plus 9, okay? Now, this is an equation of the form y equals ax squared plus bx plus c. In this course, we're going to put a big emphasis on these type of curves. They're called quadratic curves, or sometimes just parabolas. And these curves, they look either like this or like that. Whether they're concave up, which is the first case, or concave down, depends on A. So if A here is positive, so that's that A here in the equation. If it's positive, it's going to be concave up. If it's negative, it's going to be concave down. So here I already know that this is a curve that's just like that. Okay, but in addition, if I replace, right, y by 0, okay, into the equation, if you replace y by 0, well, I'm going to find, right, this is x and y here, I'm going to find values of x that satisfy the equation, and where x is a value and y is 0. So that means I'm going to get an x-intercept for my curve. Okay, so if I look back here at the two numbers I got, minus 3/4 and minus 3, it means that 0, no, not 0, but the value I got, minus 4/3, I still keep saying minus 4/3, it's minus 3/4, 0, and minus 3/0 are y-intercepts, or x-intercepts, I'm going to get this right, x-intercepts of the curve y equals 4x squared plus 15x plus 9. So let's go back here. Let's say this is minus 3. Okay, that would be minus 2, minus 1. So that means that the curve y equals 4x squared plus 15x plus 9 crosses the x-axis right there. And minus 3/4 is somewhere here. So that's the other x-intercept. Knowing that the value of a, which is 4, is positive, my curve is concave up. So I know that the curve that I need, if I were to graph this curve, it would look like this. In addition, I get also an information from that curve. You see here that constant 9 is what I get if I replace x by 0. So which means that when x is 0, y is 9. So that is my y-intercept. So here I've got all the x and y intercepts for my curve. But by solving the equation, okay, the numbers I get are the x-intercept. Let's do another one. Got minus 4x squared plus x equals 0. Okay, I want to solve this. Okay, I solved this. Well, greatest common factor first is the thing you want to... I didn't check, right? Well, I actually sort of did check, but before 4, 15, and 9, they have nothing in common. Actually, 4x squared, 15x, and 9 have nothing in common. But here, 4x minus 4x squared and x, they have x in common. So I can take out the x. And now it's factored. I can use the zero product rule. So x is 0, or minus 4x plus 1 is 0, which means that x is 1/4. Okay, so that means that 0, 0 and 1/4, 0 are the x-intercepts of y equals minus 4x squared plus x. What would be the y-intercept here? Well, replace x by 0. You get that y is 0. So 0, 0 here is both an x and a y-intercept. So we can add this is also the y-intercept. So if I would graph this function here, what are the two x-intercepts? 0, 0 and 1/4, 0. So imagine this is 1, 1/4 would be somewhere here. Okay. And is that a... So if I'm graphing here, y equals minus 4x squared plus x. So now minus 4, which is the coefficient for x squared, is negative. So this curve is concave down. So it would look like this. Okay. And one thing I didn't do, but we're going to do eventually, we're going to be able to find the lowest or the highest point, which is the vertex. It's actually pretty easy to obtain for a parabola. So for or a polynomial of degree 2 or quadratic, those are all equivalent. The vertex is halfway in between the x-intercepts. So here you see the... If I were to look for the x coordinate of this vertex, it would be basically halfway between minus 3 and minus 4, 3/4. So I can get that by taking their average. So if I take the average of the two, I'm going to get something right in the middle. So I will. So of course you get a complex fraction here. So you get minus 12 minus 3 over 4 times a half. So that this is what, minus 15 over 8. Okay, so minus 15 over 8, and to get the y coordinate I would have to plug or replace minus 15 over 8 into this equation here. Okay, I would get something else. And here it's the same thing. The vertex would be between, I didn't write that down here. This is 1/4, 0. This is 0, 0. It's between 0 and 1/4. So this one's easy. This is 1/8. And I would replace 1/8 into the equation. Okay, so to get the y value of the vertex, you would replace x by 1/8 here. And same thing here. Here you replace x. Did I say y before? You replace x by 1/8. Like this. So you're not going to get a pretty fraction. So I'll just pause and calculate that myself and add that to the graphs. So you get minus 81 over 16, which is roughly minus 5 for the y-coordinate of the first vertex, and for the second one it's 1 over 16, which is 0.06 something. Okay?